All right. Hello. Welcome to the stream. I'm Agent Ultra. And on the stream, we do some programming. And this week, I'm going to work on a library I wrote a while ago on this stream called tigerbeetle-hs. It's a client library for a database called tigerbeetle. If you don't know what tigerbeetle is, it's a financial transactions database. It's a double entry ledger database. And it's written in Zig, if you care about that sort of thing. It claims to be extremely fast. Generally, I find it has been. Debit, credit type stuff. So double entry ledger, high availability, very high durability. Report, did some Jepson tests, glowing colors, all around solid piece of tech. And I built the Haskell client for it, because they provide a C API. And so our Haskell client wraps that. And yeah, I'm just going to do a little update to the library and work on that tonight. It's been a little while since I worked on it. And just wanted to add some, well, they added a logging API, so we have some logging callbacks to add. Bumping the version of the client library and things like that. So let's see. Oh, I got a CI failure. Let's check that out first. It's probably something silly. One of our dependencies. Oh, wide word. Doesn't work. Might need to bump the version on that to get that to go. Let's see. So in this branch, I have basically just bumped up the tigerbeetle client version to 6.67, which is not the newest, I think, but it's pretty close to the newest. Let's check the reference. Let's check GitHub, actually. Releases. Okay, like, yeah, it's 6.78, but they move pretty quickly, so 16.67 is where we're trying to build right now against. The API hasn't changed a whole lot, or really pretty much at all. Just small things, so we're going to add the logging and things like that, but I'm going to get wide word to version bump. So, what else did I change? Let's branch. Preview on the master. No. How do diff. Let's just view it on GitHub. Skadoosh. Let's look at the files changed, right? Oh, jeez. Okay, so they changed the number of values in the opaque array. Some of the TB operation names and their values have changed in the enum. Some init parameters as a struct. And a function for getting that. We're setting that. So this is the log callback stuff that I wanted to add the interface for. But the main change is that I had to update the Zig version of the compiler, the version of the compiler, and that let us actually remove some of the ELF patches we were doing to the library, to the compiled library, because they're no longer necessary on that version of Zig, which is nice. And update, well, yeah, basically updated the library to newer version 6.67, which is all in, I think, in the Nix stuff as well. Oh yeah, we did update the base to 420, so slightly newer version of GHC can be used. So we had to update the text range, so I think we have to update wide word as well, looks like, to get that to work. Let's just look up on Hackage. How about still wide word? .81, 0.8422, less than or equal to 422. We should be in the range. Roll 0.80. What version? We should be using the Nix environment so in CI, so we should be seeing the same thing. That might take a little bit. Yeah, it's like only a very minor bump on base there for 1.90. So if we need to, we'll upgrade to that. Okay, while that's going, let's just look at the code and start planning out this API and how we're going to write it. So this is just a lot of like FFI type code. So what we have is tbclient.h that gets called. Okay, so looks like we've done compiling. Locally, we compiled and linked fine here. Okay, so what the hell? What is our CI doing here? Should be using Nix, so should be the exact same. Maybe, oh, maybe, no, I should, hang on. Maybe my local environment, I don't know, maybe I switched branches and didn't update the shell or something. I don't think that's the case. But just gotta be sure. We got tigerbeetle-hs. Okay. We're on this branch. TB01667. Yeah, we're up to date. We've built it. Everything should be fine. Let's do a clean full build. Check out the repository. Try to install Nix. So Nix installer action. Okay, we built fine again here, so. That's interesting. GitHub API error. Maybe it's a cache issue. Should just retry this. Okay, like I said, let's look at the code a little bit. We'll see it, try and sort that out as we go along. All right, so we get the log callback stuff. Okay, so we got a log callback status, we got a log level, and there's the init parameters. Log. And then we have this TB client register log callback function. Which takes a callback and a debug and stuff. So we'll have to like wrap all that stuff. So our code, our client, that C client code is generated and turned and popped into here with HSC, client.hsc, a few other things. Don't think we've run it here. Okay, so we should probably do that. Yeah, it doesn't look like they have it. Let's see if I remember how to do that. No. Do I write a script for it? Nope. Okay. So, Haskell compiler, FFI compiler, HSC to HS. Preprocessor. So HS, yeah, it comes from, I guess, the standard package when you install GHC. HSC to HS. Okay, it looks like we're running 910. Okay. don't... Well, this is why we needed to write a script, because I don't think there's any special flags I gotta set for it. Do I want to do it on this branch? No. So, create a new branch based off of this one. And update TV client. Update client bindings. No, call it 1.6, 6.67. Something like that. There we go. Yeah. Yeah, it looks like I give it an input file, an output file, linker, The input file should end with .hsc. Oh, wait, we don't need this. I just have to update that interface file. Because that's all hooked in. Okay. It's all coming back to me now. Source, database, tigerbeetle, internal, FFI, client. So here's where we write all of our FFI markup, our specs and stuff, and then the HSC2HS compiler will be invoked during, like a ball actually, while generating while compiling the library. So let's add our enum. Our callback and all that sort of stuff. Where should I put it? Maybe after init status, client status. Yeah, it's kind of like meta stuff here, right? Setup stuff. Convert all this to Haskell goodness. And let's see there. That. And then we get rid of the underscores. Looking Haskell-y already. Get rid of those. And that. Okay. Now we derive equal and show for these. And same for log level. We're also going to need some storable instances and stuff like that, 2 enums and from enums instances and whatnot. Log level. Let's grab those, pop that over there. Pipe. Yeah, that's what I want. Okay. Capitalize region. Go back. Place string in region. Nothing. Go to the end. 1, 2, 3, 4, 5. And then we're done. There we go. Okay. Okay, we got a log level in that. Let's do our enum instances. So to provide from enum and to enum. We'll leave that one undefined. We'll just work on the other ones. Okay, so if I fire up my GHCID, it's just a little build tool when you're working with Haskell Interactive and slow. Hey, Twitch TD. Welcome back to the stream. Sorry if I'm a little slow on the pickup there. Yeah, back on working on Tiger Beetle for a little bit. I decided I needed to, like, you know, maintain things, update things. So they added, I'm updating the library to a slightly newer version of the C client library, and then adding some of the new stuff that's been added, like just a logging callback API and some minor things. Let's check on that build. Is it still failing in CI? It is. Okay, that's annoying. So the Cabal, okay, this is really disheartening, actually. Nix here, I'm able to build it in my Nix environment, but the CI environment can't. So something is fishy there, and that's no good. I don't like that. I don't know if it might have something to do with, like, this caching issue or something. Yeah, Nix works on your machine. But yeah, that's really super annoying. I don't even, like, what? It's got to be, maybe it's a different, I don't know. I don't know what it is. Maybe I did something wrong somewhere at the Nix configuration? I don't know. I have to figure that one out. That's really weird. Register log callback status. How about that? Yeah, that is what it is. GHCID, what's going on there? There we go, that's better. Okay, so this is the hole. We need the from enum hole, right? Do we use the kind of pattern we use here is like that, so we'll continue that. Pop this over here. I'll grab all of these. Let's do it like this. Barrel. Ta-da. 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 Bang, bang, bang. Then we want to use consts. Hash const, that's like a preprocessor directive that HSC2HS understands. And we're just going to use the C value there from the library. I will grab here as well. I'll just pop those there. Dirt. That one there. This one here. Get rid of those. GHCID looks like it gets a little confused with HSC stuff. Maybe it's not super well integrated, I guess. Kind of integrated, but it looks like, I don't know, on code reload, it's like, All right, and then 2enums, just basically the opposite of that. I'll put that in parentheses, right? Pop that. There. Take this one, pop it over here. That. Capitalize region. Place a string there at the bottom. Grab this one. Down. And then we have our instance for this. So we take the TV off. There. Okay. That should be good. You got it. I think the TVs I want to get rid of on here as well. Okay, and then we're going to do the same thing for from enums. screwed up the macro. White space back. Do it like that. Do I have... Oh, I might have a camel region. I don't have that package. Okay. Let's do it. It didn't work. That's okay. Easy fix. Skadoosh. Okay. Let's do the two enums. That worked that time. Ah, macro, what up? Alright. That should be good. I'm just gonna like double reload and make sure you like this file. And looking good. Okay, cool. Alright, so the next part of this is the register log and the callback stuff. So this part, we should be able to pass a Haskell function there to the callback. And this will allow users to pass their logging in to the client library, and then the C client library will call this function, and you know, you can log your stuff. All right, it's super simple. Super easy. Barely an inconvenience. So I think it's going to be similar to the init function. We have to write a completion callback or a foreign import callback thing for our logging callback, our logging function. Similar to that. I'll put that here with the logging stuff. We'll call it logging callback. And it takes a TB log level, a uint 8, and a uint 32. And returns a function pointer. It's a type alias. Okay, we'll need something like that for our logger as well. So let's pointer to uint8. So it's a pointer to a word 32, a uint8 and a raw uint32. You're gonna copy. Okay. All right, void, so turns unit basically. Oh, okay, yeah. Sorry, got that. Make logging callback. Takes the TB call, TB logging callback. There we go. There's a function pointer to it. And then the last piece of it will be actually implementing this function wrapper for that, which oddly enough also looks like it takes a flag. Debug the logging callback. Do that. Put that here. And the name of the function to here. And then our naming convention is basically like that. Okay. I don't know why it's formatted this way, but it is, so I'm just going to follow it. Right, so this takes the function pointer, the fun pointer, to our TB logging callback. Boolean. That's really annoying. And then returns an IO of a TB logging function, enum, isn't it? Register callback log status, callback status thing. Of that. Oh, can't be marshaled. Two enum not enough. Log level enum. That can't be right. I don't think I gotta write storable in for enums, do I? Imagine for structs, but alright, let's look at the completion callback again. That's just a CUIN pointer, I guess. So that's marshallable. No. I guess I got to for that? That's kind of weird. Like, we have some marshalling for, I guess, packet statuses. Here's for the storable instance of TB packet, for example. Marshallable. Okay, he's got macros for it, right? We might want to use those, actually. Okay. Yeah, I want to marshal it as a function argument, which means I usually need some kind of, usually like storable or something like that. But I thought enums would be trivially the marshallable. Foreign Marshall, maybe? Oh, that's some allocation. I guess I could maybe what can I do? Write like a word 8 with a storable instance for it. Oh, I forgot the unmatched case. Yeah, it's for two enum for these. I'll add that for log level as well. Okay, and then our storable. The minimum definition for storable is what I need to know. I think it's just peek and poke and size of. with a type def the thing to TV log level. I don't, this isn't feeling like the right pattern here. Can't help but shake the feeling. Still TV account. Binary instances for TV create count results. Marshable. Yeah, it's still a record. Again, a marshalling of the flags and things like that, but in storable, it's just purely for the records and the structs. Yeah, Would this work if we just do something like that? No, that's not the right macro. Whip out. Oh, it is. Not enough arguments to it, I guess. Yeah, again for structs. What does the Slopinator say? I'll just use Seant, because that's what they are at the end of the day, I guess. I guess. I don't like that terribly, but yeah, the historical instance doesn't make sense for these things. Oh, another one, okay. So it doesn't like our register callback log status either. Well, that's not acceptable. TV client status is marshalable, apparently, but it's only got enum instances. Make it a Seant as well, I guess. And then we'll just wrap it. Like that. TV register log a callback. We'll take our TB log level. We'll take our function. Callback. Should we pass the debug flag? Maybe. I don't know. We'll put it in there because it's there, right, on 131, so might as well. And this will return our DB register login callback result status. Like that. I don't know, GHC really doesn't like working with HSC files. It's kind of annoying. All right, so in here, we just have to call our C TV client register log callback C function, foreign function. And it's an IOC, and so we'll get the raw status back. And we will 2enum the TV log level. The function callback will have to callback pointer. And we can pass the bool right through, I think. That'll have, that's marshallable. And then once we have that, we return pure from enum raw status. What is missing to do is that. Oh, I misspelled it. Make. Oh, sorry. It doesn't need the login level there. All right. Okay, cool. Type match error. Int with callback status. Oh, 2enum? Convert that cint to an int. There, okay. What's up, Checksor? How's it going? Hope you're doing well. Awesome to hear. Okay, so we added the register logging call back to the low-level API. So now we should be able to add it to the higher level stuff. Assuming that all compiles. Which GCID thinks it does, but I'm just going to do a Cabal build on it. Okay. At least my Nix environment does. For some reason, the CI we have set up on GitHub, that environment is not the same. I don't know why yet, but that's super annoying. I thought Nix was supposed to solve that, but it's probably me not understanding something or doing something dumb. Because I don't know Nix very well. Okay, you did hear Nix check, sorry, you did. So my local build environment, you just saw me, I just ran a Cabal build just fine. Compiled, linked, and everything. Alright. But our CI environment, which should be using Nix as well, and hopefully like the same Nix environment, gets a dependency resolution error with Cabal instead. Not really sure why. Yeah, that's all you can say, really. Sorry to hear that. I feel for you. It could be this cache. I don't know. Could be a problem there. You know, like I think I'm running the same environment, but it's not. Maybe there's subtle differences. Because this CI environment's installing Nix with this like determinate systems thing. It's setting up a cache. I don't know. Maybe it's got like, maybe this error has something to do with it. It might be a pain to fix, yeah. But also super boring to fix, so I don't want to do it on stream. So we'll just work on that, and I'll fix that on my own at some point. No, I can't. That's the thing. It's supposed to be the same environment, right? It's supposed to be deterministic and reproducible. But only if you do it right. Only if you're holding it properly. So, skill issue probably. Okay, so going out of the FFI layer, we're going to go up a level higher. And maybe we'll put it... Maybe we'll create a new module. Prefix database. Makes sense. And we'll put our nice like types here. And we had logging callback and register log callback status. I probably want the prefix on these so that I know they come from the low level, so that I can import them higher up. Although, maybe not. It looks like we designed this to be imported qualified, so let's do that. Checks are, I do, yes. Yes. I am working on a game right now. Getting fairly far with it. And I'm trying to get it over the finish line to a demo. And then once I have a demo ready, I'll put up an itch.io page for it. I'm kind of doing that project like in between when I'm not working on like my open source libraries and job hunting and stuff like that, you know. That one's like in C, not Haskell. Unfortunately, I did do the game in Haskell. Just going to steal these. Generate or validate Sudoku or Nonocross puzzles. Yeah, generating... It seems like those would be dual problems, right? I'm not sure how you would represent that if it were. But... Sat solver is what I was going to say. Yeah. Sat solvers or just constraint solving. Yeah, you could probably just write a very specialized constraint solver. You don't need a general one. But there exist general ones like Z3 or something like that you could probably use if you wanted to. It's pretty fun to try. I think Bird actually wrote a very interesting one in functional programming pearls. Pearls of functional algorithm design. He had a very interesting approach in this one, and you can see it on right on the cover. Let's see if they let us read it here. Sudoku? Yeah, simple Sudoku solver. Alright, so it defines a type of matrix and row, very simple. And just some aliases. Where to start with writing a constraint solver? Okay. There's a... I think it was called in a weekend. If I find the link, the article, it was a game dev article, actually. Which I'm not finding. But they're pretty... It can be pretty straightforward. How would I explain it? Let me grab a pen here so I can draw. The basic idea is that you would set up your state space as a bunch of variables. Right? Right, variable 1, variable 2, variable 3, whatever they are. And the possible values of that variable is, at the beginning, initially, infinite. Now, does that make sense? So, like, if your state space is like the numbers 1 to 9. Alright, so initially, variable 1, 2, and 3 are all like this. They all have the potential values of 1 to 9. And then you pick a value for a variable. Say for variable 1, we pick 3. Right. You also have a bunch of rules now that you need to propagate to the other variables based on the constraints you're trying to solve for. All right, so this will be like functions that would say, okay, now that variable 1 has been narrowed down to 3, what happens to... The rules will tell you what happens to variable 3 or variable 1 and so on and so forth. The variables that depend on 1. All right, and so they would eliminate some values, presumably, from the domain of those variables. And you keep going like that until you have a satisfaction function that tells you when all your variables are set and you're done solving. And then some cases you might need backtracking. All right, so you have narrow, you have propagate, so propagate your constraints, and then you have backtrack, but optionally. And then you have the variables and stuff. The bird in algorithm here is kind of interesting. Similar idea, like expand. He has a validation function, which gives a very high level version of it. And then, yeah, and then it's all about narrowing down again by pruning. Yeah, well, I mean, it happens when you keep reading stuff like this. You build it up over time. Yeah, I did a talk many years ago at a PyCon, long ago, on constraint solving actually, and for game design specifically. I wish I could find that paper because it was pretty cool. The idea is like, yeah, you write very like domain specific, like very specialized solvers, and you can do some neat things. And in the case of game design, it was like laying out randomly generated or procedurally generated maps. Right? And so the idea is that you want to have like a big dungeon map, like a 2D dungeon map, and you want an interesting map when you procedurally generate it. You don't want like a boring one. And an interesting one might be that like, okay, you have your starting player in a starting position, you have like a monster on the other side of the dungeon, like a boss monster on the other side of the dungeon, you have like a weak monster somewhere between the two, and you want to make sure that there's a health potion just before you reach the boss, always. Right? And so it's a bad level if that doesn't get generated, and it's a good level if it is. And so you write a constraint solver that says, okay, only good levels can be generated. Follow this pattern. That's kind of the idea. All right. Which is pretty useful. Because you don't want like oatmeal-y bad levels just because you're using procedural generation. So that's led me down to that. That led me down all of the constraint solving stuff. And then there's another book too that has some stuff on it in practical AI applications book. PAPE. No, that's not it. Practical artificial intelligence programming. I can't remember the name of it, but yeah, the PAPE book, I think it was in. Paradigms of Artificial Intelligence Programming, that's what it is. So Peter Norvig also did a Sudoku solver in Python, I believe. But this book, Paradigms of Artificial Intelligence Programming, has a lot of really cool algorithms in it. Pre-LLM stuff. All that, but yeah. Useful nonetheless. Okay, so that's our high-level logging types. There, we need our function as well, but then where did I put the low-level stuff? Goes in raw. That's right. So this is where we kind of meet the low level with the high level. All right, so we call the FFI code in here, Because calling the FFI code still, like, you need to use the FFI types and all that. Yeah, we want to provide a nice little, like, Haskell-y layer on top of it, so like users of the library don't have to, like, call FFI code directly. And, like, call our FFI types and all that stuff. Yeah. And what sort of ideas have you been coming across, Checkstar? What sort of things are you coming up with for teaching PLT and math topics in an engaging way? Yeah, they are, I find. Okay. News reporters tell stories. And so you would tell the story of the mathematics as you're teaching the mathematics itself? Mm-hmm. Cool. So Checkstar wonders what reporters learn at Shoot to make engaging stories, or at school. Yeah, rhetoric. I don't know. I've never been actually a reporting school. I'm just making that up. But I imagine they understand like rhetoric and like polemics and like various writing and arguing and techniques and stuff like that, along with other things, general writing stuff. Yeah, I'd say that's true for most things. The hard thing with mathematics is, like, I think, always has been connecting it to everyday life. And I think in some ways it's a bit of a, I've read, at least from some people, and I think I agree, that it's a bit of a mistake to always teach mathematics in terms of its practical applications. Right? It's like mathematics is always in service of something else, like physics or medicine or whatever it is, right? Engineering. And there are some beautiful subjects that, if you try to give some kind of practical example of like, why is this important? How does it relate to my everyday life? You're going to miss the point of it. Right. And like, it's going to be hard to explain in general too, like category theory and abstract algebra and sort of things like that. But what they do teach is like, I think by learning mathematics and forcing yourself through it is like how to think. And not in like the, well, I have thoughts, therefore I know how to think way, but like in a disciplined, precise kind of way where you can't cheat yourself and you can't make things up. Yeah, it can be useful. Like, don't get me wrong, it is a nice way to teach things, like calculus and stuff like that, for sure. It's interesting. I'd be very curious to see what you come up with. You should try writing some things and seeing what happens. So here's where I'm going to put the register logging callback function. Cool. Yeah, please do. Report back. Tell us how it goes. Okay, so the registering callback, let me split vertically so we get the DB register callback. So for the TV, we don't have to give anything like that. We just have to give the function pointer. You have to give the func pointer to init client. And okay. There's probably a reason we do it that way. The TB login callback, and we just return the M. TB register log callback states like this. GHCID should be a little happier with this module and reloading it, so hopefully this will work. Okay, yeah, this all qualifies. I think we import the types. Yeah, so we should do that as well. Don't know if we need TB log level, but we do need the register. I'll call back. And logging callback. And I don't think we need client pointers, so we could just really call register log callback. We put the bool flag there. Yeah, I don't know if I want to expose that, but we'll put it in there. This is an interesting type mismatch. Okay, maybe we need to lift it out. Maybe that was it. Oh, right. This needs to be a fun pointer. Change that to that, and there we go. Okay, now we just need bool. Which is just debug. It has to be exported. Okay, and then we can just replace that with that. I think we'll be good. No, has to be. Something like that. It was good to see you, Chexor. Thanks for the chat. We'll see you around. Happy hacking out there. Okay, so now that we got the raw client stuff implemented, the higher level, even higher level client.hs. Can export it. Maybe we'll put it in logging. We'll just basically re-export it. Because it's pretty... Well, except for the fun pointer part. Actually, we'll make a slightly nicer one where we'll build the function pointer here for you. Actually, that's gonna be tricky. Yeah, because the sea level, at the sea level, the callback takes a, we'll give you the sea enum here. All right, so it's gonna give you like that word 8 or whatever it is, right, value. And we're not going to have a chance really to interpret these as Haskell types. All right, you as the unless I can figure out how to marshal the enums. If I can figure out how to marshal the enums, then we could do it. And you can give me, the library, a Haskell callback function that takes a log level as an argument, a word 8, and word 32. That could be your function. All right, and then we tell you if that function was successfully registered or not. Whatever that type of status. We could write this type. But unless I can figure out how to marshal that enum, it's just not going to work. Right. Because Haskell's not going to know how to translate between the two when passing as function arguments. So Haskell, as much as possible, will actually compile to the architecture's local like calling conventions, which is why like it's fairly strict on being ISO like C compliant with all the objects that it can marshal back and forth to. So this would really be like a word 8 maybe, or if we want to leave ourselves some room, a word 32, but probably like a word 8. And you're just going to have to know as the user that this first argument is actually, you know, that enum, a TB log level, and that there is a to enum and from enum instance for log levels. But you'll have to call those manually and then inspect those. In order to call it, you know. That's basically, if I try to do it like this, right, I'm gonna get my callback pointer from that make logging callback function that we defined. If I pass that in here, it should actually get mad at me. For some reason, it's not even showing me the whole. Oh, I haven't added this file to Cabal yet. So we should do that too. Now it should complain at me. It's going to complain about my imports first. Yeah, I shouldn't even be doing that in this module. I'm going to go back to putting that in the raw. Oh, we could actually at this level, we could do a word 8 here, and that would be fine. Which is just word, not word 8. Yeah, data.word. I just haven't imported. Okay, fine. Data.word. There we go. And then we want to convert that to C ints. So Swift to Marshall. Or CU char. Word H should be fine. That's because this type is wrong. That's gotta be IO, friends. And then this has to be lift IO then. Right, and then logging and get rid of this low-level call. This goes back to being a little bit more simple. Just being lift IO of the register logging callback, the callback, and our debug parameter. Yes, it's right. That was not a scope because that comes from control monad IO class. Okay, we need to capture that result and convert it back into our higher level type. So because the callback function needs IO there. And then I think we're good, hopefully. Yeah. Okay, and then maybe I want just a callback to re-export. And lambda case, gotta enable that. These go like this. And we're going to import, that's going to be raw dot. It's just going to be the same there. Just the local one. There we go. I don't know my formatter use. Okay, cool. So that's a register logging callback. So that's the high level-ish one now done. So the only thing is, again, with this API is that until I can figure out how to marshal that argument, the user writing this callback is going to have to know that this is a C enum type, not actually an int, and that we have these enum types available so that they can pattern match on them. So maybe I should figure that out, but it looks like we're out of time for the stream this week, so I'm going to push up this branch. As a work in progress commit, what we got so far. Add logging callback, registration callback. Boom. Boom. Okay. So thanks again for watching the stream and hanging out with me and doing some programming. All the code you've seen tonight is for a project called tigerbeetle-hs, the Haskell client library for the tigerbeetle database. Tigerbeetle database being one of the fastest financial transactions databases, a double entry ledger type database, very durable, very powerful, and this is the Haskell client for it. It's up on GitHub. I'm Agent Ultra. I'm Agent Ultra on GitHub. I'm also Agent Ultra on Mastodon in the Fediverse, on the types.pl server, and at agentultra.com. It's my website. You can find links to everything else, including my YouTube channel, where I back up the VODs for this stream, and many more things. So, thanks again for watching. Go to the link above my head. It's declarative.tv. There are other streamers out there looking for an audience for things like Erlang and Elixir and even Haskell as well, declarative programming languages. There's also a link to a Discord server on that site, so if you want to chat with us and hang out with us, functional programmers and weirdos and hackers in between streams, you can do that as well. And that's all I got for this week. So thanks again for watching. May all your monads be free and your types always check, and happy hacking out there. Take it easy.